The world is on the move. With access to different kinds of transport, the distance barrier has been drastically reduced. But each mode of transport comes with its own risk factors. And that is what we're going to explore in this episode. Issues connected to car, train and air disasters, and ways in which science can play a role in reducing and containing them. Let's look at each scenario separately. First up, let's hit the road, which is what every Indian seems to be doing. We have an alarming data on the number of cars on the road. It touched an all-time high in 2017-18 with 2.49 crore vehicles being registered, which is about 68,418 cars a day. Now, do so many vehicles on the road translate into a disaster? Pretty much. In 2017 alone, over 1,47,000 people were killed in road accidents in India. Just to put it in perspective, that is more than the number of people killed in all our wars put together. This translates into 1,260 road crashes every day. One serious road accident occurs every minute. There is one death every 4 minutes, all due to a road accident in India. The data is actually very scary. So what causes these accidents? Data shows that the driver's fault is the single most important factor responsible for accidents, followed by defects in motor vehicles, defects in road conditions, and the presence of pedestrians. So what are we doing to handle this? We head to the Central Road Research Institute in New Delhi to see some of the measures in place to improve road safety. One way is actually improving the road design itself. Let's take the Greater Noida Expressway, which is very prone to accidents. What can be done to make it safer?
So we gave a holistic solution to them for this existing road. What sort of safety recommendations which need to be put on the road to make it safer for different type of road users who are using the road.
For example, there are mechanisms here to monitor driver and vehicle behavior. Besides CCTV mechanisms, there is actual physical monitoring of safety mechanisms by experts from the institute. Infrastructural changes have also been worked in. For example, earlier road dividers used to be made of concrete. In a car accident, this would add to the risk of injury or fatalities. Now, these are made of shock-absorbent materials, and this reduces the risk to some extent.
Basically, to address these safety-related issues, there is a concept which is followed in Western world and also in India also since around 2000. There is a concept called as a road safety audit. In Indian context, you can expect even the pedestrians may tend to cross the road at any location. So that need to be addressed from where is the appropriate location for them to be given the provision for crossing the road. So that we try to investigate it as part of the design stage audit.
Technology has also been used to understand driver behavior in an attempt to reduce risk further. And so, the CRRI has devised an innovative driving simulator. This will try and catch some issues that could hamper good driving on the road, like inadequate attention, poor reaction time, and inadequate hand-eye coordination abilities. The software has worked in a range of typical Indian road conditions like potholes, behavior on the road like wrong side driving, and varying traffic. And this will make it easier to predict the kind of traffic violations, errors of breaches of safety that a driver could commit. and may keep some unsafe drivers off the road, especially if the simulator is easily available at all transport authorities across the country.
We have the actual cars and accessories inside the vehicle. So everything is actual. Just the virtual screen is there to find out how it react. And there are certain kind of actual hazards on the road, right? Some dog is coming suddenly, the driver may not know that dog is coming, but the instructor can conduct those things, insert those things on the road.
There are other new wave devices like the Tobii Pro eyewear that can help predict driver behavior. These glasses help us gain insight into driving behavior. For example, it can sense if you are driving without awareness, which is whether you operate a vehicle with little or no conscious attention to the surrounding traffic. Again, spotting behavior like this can make our roads safer.
Suppose there are road signs, whether the driver is actually concentrating towards that road sign or not. So appropriately what infrastructure is concentrating on the road, that is very important. So eye tracker is for that very important, paying attention on the road what kind of infrastructure is that. Also he is taking attention inside the vehicle. So what kind of attention he is taking, that minute by minute, that is recorded inside the system.
Car manufacturers are also working on a range of safety devices like seat belts, anti-skid braking system and airbags. And these may help make road safety a reality. Most cars today have an anti-lock braking system or an anti-skid braking system, also known as ABS. This is an automobile safety system that allows the wheels on a motor vehicle to maintain tractive contact with the road surface while braking. This prevents the wheels from locking up and avoids uncontrolled skidding. Another critical safety device in case of a collision are airbags that can hugely ease the impact. When a car crashes, the passenger is thrown forward because the car's momentum has changed while the passenger's has not. What an airbag does is to slow the passenger's speed to zero, all the while cushioning his or her impact. To ensure greater safety on the road, the government has mandated the use of ABS and airbags in all cars. In addition, they have also suggested that all cars come with speed monitors, reminders to use seat belts. There are also plans to set up the Bharat New Vehicle Safety Assessment Program or BNVSAP, which will also rate vehicles on safety. Another important aspect of road safety is the tire, the sole point of contact between the vehicle and the road. Now there are numerous issues that affect the tire performance and safety on the road, like the tire pressure. Only when the tire is properly inflated will it adhere well to the road, so low and high pressure are issues. The size of the tire tread and wear and tear on the tire are also issues to be monitored. Now a tire bursting can cause you to lose complete control of the car. Now one of the common reasons is heating. As the temperature rises, the air inside the tires get hotter, leading to an increase in pressure. Along with that, there is also friction between the road surface and the tire, which is making it hotter from the outside and weakening the rubber. Hence, hot days can cause more bursts. Now, one way of preventing this is actually filling your tires with nitrogen. Let me explain in more detail. Since air is 78% nitrogen, this gas is less likely to migrate through tire rubber than oxygen. This means that your tires will exhibit less pressure change with temperature swings. That means more consistent inflation pressures as the tires heat up. Now, this does prevent accidents but does not stop them completely. There have been incidents where nitrogen-inflated tires have exploded. Many issues, each with their own bag of solutions. With all this, hopefully there will be some small reduction in the number of deaths on Indian roads. After the break, we will explore how science is being used to make the Indian Railways safer. Keep watching. In our study of transport disasters, we move from the road to the track. The Indian Railways has always been a source of pride to the nation, and rightly so. It is the largest rail network in Asia and the world's second largest network operated under a single management. It has 1,15,000 kilometers of track length running through over 7,000 stations. It runs 12,617 trains that carry over 2.3 crore passengers daily. To give you an idea of scale, that is roughly equivalent to moving the entire population of Australia. The question that then arises, how is it possible to ensure safety in this mammoth enterprise? Especially because this is also one of the oldest railway systems in the world. It is not like there are no accidents, but data from the Traffic Railway Board shows that instances of accidents in the railways has reduced by 15 to 20% in India. In spite of this positive trend, there are still accidents which the system is working very hard to reduce. And so, there is a constant review and monitoring to improve safety using modern technology and innovation. Let us look at a few examples. Many derailments are the result of a rail fracture. A rail fracture is very simply a crack in the track. Sometimes these small cracks turn into larger ones, usually because of the pressure of heavy bogies traveling over the track. This is more likely to happen in seasons when there is a significant difference between the maximum and minimum temperatures in the day, since those cause the tracks to expand and contract. When there is a break in the tracks, the bogie goes off the rails, affecting all the coaches behind it as well. Now the Indian Railways has over 1,15,000 kilometers of track around the country and has an entire department of trackmen whose entire job revolves around maintaining tracks. These 2 lakh trackmen set out every morning carrying 15 kilos of equipment and walk along a 5-kilometer stretch of rail to inspect each inch of the railway tracks, making sure that no nut or bolt is loose. It's a painstaking and tiring job. Whenever they detect flaws in rails, these are replaced. This is a process that is constant since it is critical to ensure the safe passage of our trains. Today, this kind of testing is also being done using ultrasonic testing equipment. This is run along the entire length of the track. The waves being sent out from this machine penetrate the track. The reflected signal is captured and analyzed and can indicate if there is any crack in the railway track. There are other innovations in place to make travel safer. Take the Train Protection and Warning System or TPWS on trains in the Northern Central Railway. How does this work? We decide to explore it on the Gatiman Express, one of the fastest trains in India. Now the train is picking up speed. The moment it crosses a speed of 160 km an hour, an alarm will go off. And the system will automatically apply brakes and stop the train. Similarly, if the train approaches a signal too fast or fails to stop at any signal, brakes will be automatically applied, bringing the train to a stop.
If there is a train crash, a train accident, then we know it's a disaster because many more people are involved. So a lot of automated systems are introduced, and also not just that, if one layer of automation fails, what can be a second layer of safety which can come into the picture. And this is all based on a lot of intensive research.
With the increase in train traffic, many trains run down a stretch of track. The regulated distance between any of them is 500 meters. But then there is a risk of one colliding with the other. To prevent this, there is a technology in place. If the trains are closer than this prescribed distance, there is a warning that goes off and the driver of the second train is made to proceed at a reduced pace. If the distance is dangerously close, the second train is made to stop.
Because all these are what is called complex and non-linear systems, which means that the outcomes are not very easily predictable. So for such systems, the thinking came that we have to make the systems safer. We have to build several layers of safety, so build in redundancy in the system.
Fast-moving trains are at risk of collision, but there is also risk of slow-moving trains at stations and depots colliding, especially in busy terminals. And so, there are systems in place to monitor train movement in a station. A 24/7 control center makes sure trains enter and leave stations safely. They switch tracks to get trains to the desired platform or to pass through the station without making a stop. With all these and many more technologies in place, the railways are becoming hugely safer. This is critical in a world where more and more people are on the move. Next up, air safety. How does the ATC work? What mechanisms are in place to stop mid-air disasters? Keep watching to find out. From the ground, it is time to hit the air. A whopping 26.5 crore passengers took off from airports around India in 2016-17. The total number of aircraft movements increased to 20.5 lakhs and air freight handle reached 25.3 lakh tons during 2015-16. Worldwide, there are more than 1 lakh flights a day. With so many planes in the air, what are the risks of a mid-air collision? And how will we deal with it if it happens? First off, let's explore the main reasons for air disasters. The biggest reason seems to be pilot error, accounting for a whopping 50% of plane crashes. 22% are caused because of mechanical errors. Around 12% are caused by weather conditions, although flights are usually grounded when weather conditions are deemed hazardous. 9% happen because of sabotages, and 7% are caused by other human error like mess-ups at the ATC. Let's look at 2 airline disasters that made the headlines for very different reasons. The first happened in 1996 in November. 2 planes, Saudi Flight 763 and Kazakhstan Airlines Flight 1907, were involved in a deadly mid-air collision over Charkhi Dadri in India. All 349 passengers and crew on board both flights died. What went wrong and why did the plane crash? The black box on a plane is crucial to assessing information that could tell us what went wrong in a flight. The black box is a device usually kept in the tail of an aircraft where it is more likely to survive a crash. It has 2 separate pieces of equipment, the flight data recorder or FDR and a cockpit voice recorder or CVR. The FDR records at least 88 parameters about the flight, including airspeed, altitude, rudder position and air pressure. The CVR records everything the folks in the front cabin are talking about. In the case of the Charkhi Dadri flight, all the information from the black box and other sources revealed that the Kazakh pilot was flying lower than his assigned altitude. Such a small mistake and such an enormous fallout.
In safety point of view, you like to have some separation distance physically. So within that separation envelope, if the other aircraft, they come close enough actually, that's also called collision in theoretical sense essentially. So every vehicle should carry some sort of a safety envelope around it, and every other vehicle should be away from that safety envelope all the time. So then only we call that as prevention of collision.
To protect against another incident like this, a new safeguard known as the semicircular rule came into effect. Very simply, this prevents aircraft from flying in opposite directions at the same altitude, making collisions much less likely. Also, the civil aviation authorities in India made it mandatory for all aircraft flying in and out of India to be equipped with what's called a traffic collision avoidance system, setting a worldwide precedent for mandatory use of the TCAS. This TCAS has two major components: TCAS antennas and transponders. So transponders in aircraft send out key information like position, altitude and vertical speed. The antennas scan the surroundings for data from other transponders. Now as soon as an aircraft comes into this scan area, it sends a signal to warn the pilots. A critical component of air safety today is the ATC or air traffic control. The key role of the ATC is regulating air traffic, making sure that it moves smoothly with minimal delay. Air traffic controllers have access to sophisticated radar systems that provide an overview of the airspace they control. A radar pulse is basically a radio wave which bounces off an object, in this case an airplane. The reflected radio waves are picked up by an antenna and displayed on a screen at the ATC. Most aircraft today have a transponder. When this receives a radar pulse, it replies with a 4-digit code that is set into the transponder by the aircraft pilot. So the ATC controller can not only see the basic radar return for each aircraft, but based upon the number generated will also have information about the aircraft, its type, altitude, destination, etc. and can ensure that the aircrafts are never in conflict with each other and can sequence aircrafts for arrivals and departures. Let's move away from the ATC and look at other ways in which air disasters can happen. For that, we moved to a flight landing in Mangalore in 2010. An Air India flight coming in from Dubai with 166 people on board. As the pilot landed, he overshot the runway. The plane crashed into the valley before bursting into flames. The crash killed 158 people and left 8 survivors. Many investigations have happened to see what went wrong, with the black box again providing valuable information. The final explanation was tragically simple. The pilot had fallen asleep. When the pilot woke before the landing, he was believed to have had sleep inertia. Investigators concluded that had the pilot applied emergency braking, he could have stopped the plane in time. So this was clearly a freak accident. But there are so many possible risks that we need to guard against. Take landing in places with little or no visibility that happens mostly in winter with fog or snow. Today, many airplanes are equipped with an instrument landing system or ILS that helps landing when pilots are unable to establish visual contact with the runway. This system uses a combination of radio signals which provide both vertical and horizontal guidance, along with, in many cases, high-intensity lighting arrays to enable a safe landing. There are two main components to this system: a localizer, which provides right-left guidance. The localizer antenna broadcasts 2 lobes down the length of the runway for a few kilometers. The ILS receiver on the plane interprets the overlap of the 2 frequencies to determine the course of the localizer and direct itself to the middle of the runway. The glide slope is for up-down guidance. This equipment sends out 90 Hz and 150 Hz lobes, which are interpreted by the ILS receiver. This information will help the airplane down towards the runway at a 3-degree angle. This technology has been available from the 1930s but is now much more common in airports and flights. One more way of making our skies safer, which is important. With the scale of transportation rising, with the escalation in the use of airplanes, ships and other means of carrying people from one point to another, the scale of life-threatening disasters is rising as well. And so, innovation and technologies that make our transport safer are our hope in a world that is moving faster and faster.